All right, this is the last new thing. We're going to talk about real-world circles. So we're using all of our information about circles that we've learned so far and just applying it to some real-world scenarios, okay? So go ahead and have those notes ready to go, whether you have your own copy or print it out. And we've got a sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. What is the circumference of the region covered by the sprinkler? So first things first is we always need to know, are we finding area or circumference of the circle? And very clearly it says the circumference. So we know we're either using the pi times d, or we might be doing pi times 2r. It depends on what information they give us, okay? So when we look at this, it's talking about a sprinkler. Well, if you think of a sprinkler, right, it'd be like the sprinklers in the center. And it says it's spraying in a circular pattern. So it's like, all right, I'm spraying out and it's going around in this circular pattern. Okay? So when they're saying it sprays it over a distance of 12 feet, that is, okay? Because it starts from the center, right? It's not spraying out of both sides or whatever all over the place. So it is talking about the radius for that one. Okay? So we're going to be using our pi times 2r. Yes, you can obviously still do diameter if you want to do that 2r in your head. That you're more than welcome to do that. But I just want to make sure we're realizing that we are using the radius for this, okay? So I'm going to go ahead and set this up as 3.14 times 2 times 12, okay? And if you want to do that 2 times 12 part, feel free, or you can just multiply those all into the calculator. You decide. If you want to pause and try that on your own, feel free. But when you do get your answer, it should be 75.36. And since it was circumference, we're just going to have just feet. Okay, so that would be just the circumference, not the whole spray, but like just like, okay, this is how far it reaches. All right, if the springer's in the center, it's reaching that amount of area. Okay, or not area, the circumference, the around. So let's look at just one more, because these really are what we've done before. It's just a matter of putting it into words like this. So it says the sides of a square field are 10 meters. A sprinkler in the center of the field sprays a circular area with a diameter that corresponds to a side length of the field. How much of the field is not reached by the sprinkler? So let's piece it together, right? Let's first figure out, are we doing area or are we doing circumference? Well, since it talks about area right there, that's on as area. But if you notice, it's talking about the area not reached. So let's picture this for a second. We've got a square field, okay? You got the sprinkler in the center, and it's spraying an area around, okay? I know I didn't draw it perfectly, but right, like it's going to spray that area, and we're talking about all this space inside, okay? So the areas are these corners, oops, one sec, of the square. So what we can do is find the area of the square, find the area of the circle, subtract, and that'll give us these leftover spaces of where the sprinkler does not reach, okay? So the area of the square is pretty simple. It's just going to be 10 times 10 because that is, it says the sides are 10 meters, and so we get 100 meters squared for our square, okay? And so for the circle, we need to figure out, okay, it says that the diameter matches up to the side length of the field. Well, if the side length of the field is 10, like we figured out before, we know, I don't want this to be confusing, I'm sorry, this is representing the circle. We are finding area. I'm sorry, I just realized that could be confusing. Let me just put an A in front of it. Okay, oops, sorry, my pen is not happy with me right now. There we go. So we're finding the area of a circle. That's what that means. I know it's a little goofy looking, but it just kind of helps clarify a little bit. However you want to label that, you decide. Anywho, so the diameter of the circle represents the side is corresponding with the side length of the field, which is 10. So if we're finding area of a circle, we need pi r squared. So because this is the diameter, we know that the radius is going to be 5. So we want 3.14 times 5 squared. Okay, so go ahead and type that in your calculator. Again, you can do the 5 squared as 25 if you want. But when you type that all out in your calculator, you should get 78.5 meters squared. So the last step is to subtract okay? Because we want to know what is not reached by the sprinkler. So the sprinkler will get 78.5 meters squared, but the square is 100 meters squared. So we need to subtract to figure out, okay, these corner pieces, when we add that up, how much area is not being, getting the water from the sprinkler, okay? So when you do that, you should end up with 21.5 meters squared. Oops. There we go. Goodness, my thing is not working, but you get the idea. Oh, goodness, sorry, that pen is messed up. But 21.5 meters squared. Sorry about that. All right, so you have one practice problem to take a look at. I'm going to read it to you just because the most important thing about this is annotating to figure out what do you know versus what do you not know. So just really pay attention to it. So it says a stained glass window is shaped like a semicircle. The radius of the window is 6 inches long. What is the area of the stained glass window? So there are some key things in there that you should be seeing as I read that. Just like yesterday, go ahead and solve this problem. However you post on Seesaw your work and your answer. Don't forget that label. Good luck. You can do it. Feel free to go back and take a look at something.